have her to present to us in the area of fractions and looking at multiplication and division of fractions. I'm asking you to spend the time to work with her and to interact so that we all can have a wonderful evening. Welcome, Mrs. Mills.
Thank you, Miss Marissa. I need to be some form of co-host so I could share. Good afternoon, colleagues. As Mrs. Morrison said, my name is Miss Sharlene Mills. I'm a teacher of mathematics. Or just let me share my screen. A second, please. Okay. Are you all seeing my screen?
Yes, I am. Where?
Okay. Let me. Okay, so again, good afternoon. Welcome to this virtual space. My name is Sharlene Mills, and I'm a teacher of mathematics for almost 20 years. Just like almost everyone here, I'm not really a person who talks a lot. So you will not, I'm not a person of speech. I cannot give speeches. So you will not see any speech or anything, get any speech or anything from me, but we'll just get into the meat of the matter. I know that most of you are tired, just like myself. And I also know that you just want to go into your bed and relax or prepare for tomorrow morning. So I won't have you long, but however, I want this to be an interactive workshop. So I'm anticipating your participation. Looking forward for a productive and well-spent afternoon. So for us to start off, you know, sometimes we're a bit tired, but to get you in the mood, I'm going to do some simple icebreakers. And I'm pleased, I know that sometimes you're there, you don't want to talk, but I'm begging, seeking your interaction. Are you hearing me clearly, everybody?
Yes, we are.
Okay, thank you. So as you look on my screen, this is something, I don't know if anybody is used to something called Bitmoji. It's like a app you can use, you create your own avatar and it speaks for you. So you can, whenever you're doing your PowerPoint, use the Bitmoji. Maybe some persons are familiar with this. So it makes your PowerPoint look kind of eye-catchy and, you know, maybe will not send you to sleep. So, okay. So the first one is, what falls but never breaks, what breaks but never falls? Anybody? You can just raise your hand and we'll just identify the person. What falls but never breaks, what breaks but never falls? Just giving you about 30 seconds or so to answer. Okay, go ahead, Darcia.
Rain.
Rain, no, rain, no, not rain. One more person. What falls but never breaks, what breaks but never falls?
Trudy, you can unmute your mic and speak now.
Okay, thank you for monitoring that for me, please.
All right, Trudy Morgan says tears.
No. Okay, so nobody gets the answer. That is the answer. Night falls but never breaks, day breaks but never falls.
There was a response about that. I think it's Andrea Minot. She said,
oh, she wrote
that night and day, yes.
Okay, could somebody just monitor the chat for me, please?
Okay, so Mrs.
Because yeah, cousin.
Maurice Adams, she will be moderating, so she will be here working with you.
Okay, no problem. All right, this is another one. Use the pics to tell. All the pic is depicted in one word. Anybody? All that pick is depicting one word. Each pick is a clue. Anybody else? Hope. Okay, very good. And that's Rosemary. Rosemary first said it. Hope. Yes, that's hope. Okay, it's the admit screen. All right, let's move on. All right, so that's it. Hope. Let's move on. This is another one. Persons are typing in the chat.
Mhm.
Yeah.
We're waiting the response for that one.
Okay. Look at the pic, the colors, what colors are here? Somebody typed.
All right, Brenda Thomas.
Primary. Yes, that's correct. Primary. Right, primary. Very good. And the last one now, as we are in a math workshop, so arranging numbers from 1 to 9 so that each row and column add up to 15. They can just tell me after you have done it, you can just tell me what numbers you got in the first row, what numbers you got in the second row, and what are the numbers in the third row.
I am not seeing a raise hand button here. May I respond?
No
Go
problem.
ahead, Shadia.
Okay.
All right. So I'd put 5 in the middle
Okay.
and in the left diagonal 9, in the bottom right 1, in the right diagonal 7, in the left bottom diagonal 3, top middle 8, bottom middle 2. And which
Okay.
ones did I leave out? 6 and 4, either end.
Okay, very good. And it can be arranged in any way. It can be arranged any. Somebody please, the admit is kind of right. Messing up my screen. All right, so that's it. So the numbers, once the numbers, what she did was to call the numbers, but in different position. But the arrangement of the numbers are basically the same, but in different position. Okay, so I hope your brain ready to go. So as we said, no, just a recall, what is fraction? We know that fraction is a part of a whole. Most of the time, that's what we learned in primary school. If you do research, you will see that fraction is part of a whole. Maybe some of the times when we talk about part of a whole, we just think of the number 1, but a whole can be like a group, and because it is not just necessarily mean the number 1. It shows us something. Fractions also show how something is divided. And it is, wow, okay, the admit is kind of, yeah, it's coming on my screen in front of me and I'm seeing it.
All right, what will happen, because you're also co-hosting all that, but
Yeah,
we are monitoring that. We're admitting persons as you go along. So you can ignore it and go ahead.
Okay, yeah, it's just that I have to remove it each time, right? So we know about how a fraction is written. Always have a number at the top, a number at the bottom, separated by the vinculum. That is just revised. That's not what we're really coming to talk about. We also know that fractions, we talk about fraction in real world. And this is something that I'm showing you how you can, when, for example, when you're talking about fraction, introducing fractions to students, allowing them to explore what is the concept of fraction. We can use real world situations. For example, on a daily basis, we'll tell time in hours, right? So each minute is a fraction of an hour. And we look at the example, 7:30 is 7:30, or 30 minutes is 7:30, or 30 minutes out of the 60 minutes. And it can be written as a mixed fraction as 7.5. Right? And what you can do sometimes, so for example, if you're teaching maybe lower school, I know this is for grade 4 to 6, and I also help my daughter to understand too, is when you have the clock and you use a clock and you shade different parts of the clock and allow her to tell the time, but also try to let her understand what fraction, what fraction each time is representing. And that would be for the lower students when we are introducing fraction to them. Everybody with me? Okay,
Great tips.
also, we're looking at money. Again, we can use fraction. When we are introducing fraction to students, we can use money, taking the money, so using the different, and let each group having maybe like one group having 100. So we're talking about different ways to represent $100. So one group, you can give them $20 and ask them to create, you can direct them how to create different fractions. So you know that $120, one of the $20 will be $20 is going to give you $100. So $120 would be 1/5. You can also give them some $10 to represent the $100 and let them create different fractions using the $10 and also the $50 and the $5. So these are things which you can just use in your classroom to help students to, when we are introducing fraction, to understand the whole concept of fraction. And that fraction is not just when we draw a circle or a rectangle and we use it to shade, but we can also use other real life situations to represent fraction. And again, this is the one that we use every day. A burger, you cut it in 4 pieces and each of your friends receive a quarter. Pizza, these are things that we use almost every day when we're teaching fraction. Now we look at different types of fraction, you know, mixed fraction, improper fraction, using real life situations to represent these. Now we're just revising addition of fractions, or we go about adding fractions. No, these are not really. So now when you're teaching fraction, one of the things, because fraction equivalent, when we talk about, when we deal addition of fraction, subtraction of fraction, one of the prerequisites that you can test is to activate the prior knowledge, which is actually prerequisite, is to ask students to find equivalent fractions. So you find an equivalent fraction for 3/4 and 1/3 with the same denominator, right? So you'll ask your students to find the equivalent fraction of 3/4 and 1/3 with the same denominator. And as you said, I want you to talk. So what would be the first thing? What number, what denominator are you expecting the students to derive after you ask them to find an equivalent fraction for 3/4 and 1/3 with the same denominator?
12.
12, right.
12.
So this, right, very good, 12, right? Right, so you're expecting them to create the equivalent fraction, because for them to create the equivalent fraction, the first thing they'll have to find a number where you multiply it by 4 gives you the same number that when you multiply it by 3, right? So we know that 3 times 4 gives you 12 and 4 times 3 gives you 12. So we use, and they will create their equivalent fraction. And that is what we can use to activate the prior knowledge, because equivalent fraction is what we are going to use in when we are doing addition or subtraction of fractions when the denominators are not the same. Am I going too fast?
It's okay.
Okay, because I asked that I tend to talk a little bit too fast at times. All right, so here's a scenario. Tom and Brian were each given a cake of the same size. Tom ate 1/4 of his cake and Brian ate 2/4 of his cake. What portion of this cake did they eat altogether? Now here you're teaching addition of fractions, and you're not going to, so what would be the first thing that you're going to give them? What, all right, before we go ahead, what we need for these, right? We're teaching fractions. What are some of the resources we can use in our class when we are teaching fractions? Anybody want to tell me some of the resources we can use in our class when we are teaching fractions? When we're
Crayons.
teaching basic operation on fractions.
A sheet of paper.
We can use a sheet of paper. Anything else?
Mhm.
Anything else?
Fraction pieces or fraction this.
Yeah, we can use. So we can use fraction strips or pieces, and we can use shape cutouts, because in the shape cutouts, we want the children to fold, to cut, to color. So in our fraction class, we're going to have things like we have circles. So maybe we can ask the students to carry these things ask them to cut out circles out of cartridge paper or even plain paper. Sometimes they don't really do it properly because some of them are not monitored really by their parents. But what you can do is to have different cutouts. So you have circles, you have rectangles, squares, and also you can have fraction pieces. You can create the fraction pieces. You can even ask them to create the fraction pieces in preparation for teaching fraction, because my daughter is in grade 2, and the other day I had to create fraction pieces for her. So you can ask the students to create these, or if you want as a teacher, you can buy them. Growing Minds have them, or I don't know, you can ask your principal or ask that the school buy these things for you, these resources, and so that you can use them when you're teaching fraction. So here now, so you have
Just
all
a
your
minute.
Yes.
Just a minute. We have
Yes.
2 responses in the chat from
Oh.
Trudy Morgan and Rosemary McKenzie. Bread, bulla.
Bread and bulla. Okay, yes, we can carry bread to cut up and bulla. Okay, but I don't know how, maybe it's primary school, but sometimes we ask not for those things to be used in the class, because it's going to be like an interactive class, and to use like the bread, because when you're using the bread and the bulla, I don't know, maybe it's primary school, yes, you can use the bread and the bulla, but because you want them to be, they are the ones who are going to do, they're the ones who are going to do the activity. So maybe, yes, bread and bulla can be used also. I will not say no to that. So if students are given a question like this, how would you guide them through the problem solving steps? How would you guide them? Anybody want to share? How would you guide them through solving this problem? Because you are going to put them in groups. To do this, you can put them in groups, or you can do peer sharing, whereby what I do in my class is, for example, if you have a child that is extremely bright and one that is extremely slow, I will peer share those two together, because we know that maybe the very slow one will not function effectively in a group setting. So once you place your children into group, whether you want to by peer or more than 2, but how would you go about now helping your students to solve this problem? What would you do? Anybody wants to share?
A diagram could help.
Yes, diagram. So you give them this problem, maybe on a sheet of card, or are you going to help them to solve this problem? What will be the first thing you say to them?
First have them establish the 2 cakes.
Okay, establish. So they are going to create a visual, right? They are going to create a visual problem. They are going to create a visual in their mind, right? Now, after they create the visual in their mind, what would be the next thing they will have to do?
Let them create it concrete also.
Right. So after they create the visual, they can create diagrams to help them, right? Very good. So after they create the visual in their mind, then they are going to create the diagram to help them. And then what will be the next step?
And they'll move to the next part where they'll have to show what was eaten by each.
Right. So they will have to, maybe what you could do is to ask them, what do they need to answer this problem, right? What do they need? What mathematical operation would they be performing in order to solve this problem, right? So these are some of the questions that you could ask them. What information will you need to aid in the problem solving process? So students, so after you have given the questions and they have They have the fraction. You can have the cutout, the shape cutouts. No. Tell me some of the things you are expecting your children to do. Explain the whole problem solving, how they are going to do so. They are going to create the visual in their mind. After they create the visual, you are going to ask them now to use concrete to represent this by drawing. But in this now, you have the shapes. So they have the shapes. So maybe you could give one group some circles, one group some squares, one group some rectangle, and ask them. You're not going to tell them. So they are going to know. Let them, so after they create the visual, then they are going to do the two cakes. So they must know that, okay, it's two cakes. So I'm going to take out the two cakes now. Is there a problem? No, hearing a feedback? Nobody's saying they're not hearing anything. Everybody hearing me?
Yes, we're hearing quite fine. Perhaps that individual need to exit and rejoin. Sometimes that corrects the audio problems.
Yeah, the person is talking, the person is keeps on talking. All right, so everybody with me? So after they create the visual now, when you give them the shapes, the cutout, right? What do you expect them to do now? What are you expecting? You're walking around, what do you expect in your groups? Right? You have the cutout, what do you expect in your groups?
Okay, Dawn wants to say something. Go ahead, Dawn.
Expect to see them take out the eaten part of cake. Take out the portion that was eaten out from my cutout. Take out the part that was eaten out of the whole cake, and put them together. To show me the addition.
Right. So if you have a cake now for the bulla, all right, now, so for the bulla part, you are expecting them because, so if you have the bulla in the class, now, for example, if you have the two bulla in the class, what they could do now, you expect them to divide the bulla into 4 parts, don't it? So for them to share, they'd have to divide the bulla into 4 equal parts. That's the first thing you're expecting them to do. Am I correct? Right? To divide whatever shape. So even if the cutouts are the bulla that you have in the class, you are expecting them to divide each into 4 equal parts. And then now, after they have divided it into 4 equal parts, they are expected, so the ones with the bulla, they are expected him to take out a quarter, and then the next one will take out the 2 parts. Everybody with me? Or if they are given the shape cut out, some of them will be shading, right? Or even to cut it out. Everybody with me, right?
Yes, we were reading what you had on the previous slide. Could you go there?
Okay, sorry. Right, so to derive the portion from X, each cake would have to be divided into 4 equal parts, right? And then given the pair of students are expected to divide into 4 equal parts, right? And then after they divided into 4 equal parts, then if they have the real bulla, they are going to take, one is going to take out a quarter, and one is going to take out 2 parts out of the next bulla, or they will shade, and then you can see, if they cut out, you can see that is 3. So it's 3 shared, and if it is shaded, you realize that the 3 is shared. So it would be, the answer would be 3 out of. Everybody with me? Am I making sense?
Yes, this will make it clear.
Okay, all right. So that is it. So let's just move on. And the same thing, we could do the same thing for subtraction. Same exact thing. The same thing for subtraction, right? Do the cutout or the shade, right? That you could then shade and cut out for the subtraction. All right, now here's another one now. Anthony, wow, sorry. I read it on my screen. Just a second. Read that for me, please, and tell me how would you again? This is another one. How would you solve this one?
Marlet, would
How
you
would
want
you
to
guide them
answer?
through solving this one? Somebody want just identify the person for me, please.
I think someone is, okay. Any volunteers? I'm not seeing it in the one with the raised hand.
May I, Miss Adams?
Go ahead, please.
All right, so for this one, I would have them have 4 shapes, 2 for the quarters and 2 for the thirds. For the first one, they would represent what the question is saying. It was sliced into 4 equal parts, and we gave away 3 equal slices, so they'll have that for the first one, and and for the thirds, they would have the 3 equal parts and the 2 pieces that were given. So that is what the question is actually saying. For the second set of shapes, they would have to show the equivalence. So we want both of them to have the same denominator representing the same amount. So what would be the new denominator, which would be 12? So now you
we're not going to use remember now, we are using shapes now. They are doing, so we are not using the denominator. So we are using
would be, for it to be equal, they would have to have 12 pieces to show the pieces that were taken from the quarter. So what amount would be the same size for the quarter on the new shape that they have? What amount would be the 2/3 representing the same size now that you're sharing out of 12? Then they could go ahead and do their addition after doing that.
Okay, so I said Anthony. Okay. Anybody else want to, anybody have any other idea? Any other? So it says that Anthony and Dejon were each given a pizza of the same size. So here we have Anthony was given 1 pizza and Dejon was given 1 pizza, and both were given the pizza of the same size. However, Anthony's pizza was sliced into 4 equal slices, while Dejon's pizza was sliced into 3 equal slices. Anthony gave 3 of his pizza slices to his friend, while Dejon gave 2 of his pizza slices to his sister. How many slices of pizza did the boys give away altogether? So here now, again, you lead them through the problem solving steps. They are supposed to create a visual in their head, try to imagine. So they must know that for them to solve this, they will have to have 2 shapes, right? So each group supposed to know that the first thing, one person supposed to be discussing in the group that here we need 2 shapes. One for Anthony and 1 for Dejon, but the 2 shapes must be of the same size. Now they must also know for them to share Anthony, so they know that Anthony pizza was sliced into 4 equal parts. So you're expecting them now to go ahead and do the division of the one of the pizza into 4 equal slices, right? And then the other one, you are expecting them to divide it up into 3 equal parts. No, what I want you to notice is that, whoa, what's happening to me? Just a second, guys. Wait. All right, so this is it now, right? So 1 pizza divided into 4 equal parts and 1 divided into 3 equal parts. Now, after they have done that now, you are expecting them, because if they're thinking, they say, okay then, Anthony got 3, Anthony gave away, I've not seen the question. How many? Anthony gave away 3 slices of his pizza, and then John gave away 2 slices of their pizza. So you would expect them to know shade to represent. Now, the first thing we are looking at, we could have a discussion here. Here we have 1 divided into 4 equal parts and 1 divided into 3 equal parts. Now, the question that we could ask is, are the portions the same? Is one portion from Anthony's Pizza the same size as one portion from the John's Pizza? No. You expect them, they are going to say, no, miss. Okay. No. If being that Anthony Pizza is not the same size, one size is not the same as the John, what are we going to do? Maybe some of our students are going to say, Miss, me get the answer. It's 5 sizes of pizza was given away. Okay. No. All right. A student said to you, Miss, what is 5 sizes of pizza? Anthony gave away 3 and the John gave away 2. It's 5 sizes of pizza were given away altogether. No. How would you guide your students? If a student said something like this, how could you guide them from this point forward?
This is where equivalent fractions come in.
Right. So this is where equivalent fractions come in. So what could you use to help them understand, to know that here is at a point where we have to ensure that once we are sharing, each portion must be of the same size? What could we use? What could we use to help them to understand?
You could use a paper folding method where you have one paper divided into 4 equal parts using vertical lines, and you shade 3 parts in a particular color. And then now you have another paper that's divided into thirds. You shade 2 parts out of that 3 equal parts using horizontal lines. Then you put then you're going to ask them to put the vertical lines on the ones that are on the horizontal and the horizontal lines on the ones that are vertical, so they can therefore make the like fractions, make equivalent fractions out of them that are like fractions. From there, they can count the number of shaded parts and they'll see that really one portion is greater than the other, and they can eventually count them, do their subtraction to count or with their calculations from then on. But they will have to make these 2 unlike fractions into like fractions. A paper folding method is one good method.
Okay, paper folding. But you know that just to explain it sometimes can be explanation sometimes, and the whole can maybe cause confusion for some students, you know. So that's a good way of paper folding. But as I was saying, one student might say to themselves that Miss, is 5 slices of pizza, 5 slices were shared. So what are you talking about? But you could say, okay, if I have 3 bananas and you have 4 bananas, how many bananas would that be? We'll say 7. Okay. I have 3 apples. You have 2 bananas. How much would that be? Right? So maybe some of them are going to say 7 apple banana. But what you would get from them to let them see, okay, 1 is apple, 1 is banana. When you put them together, they are not the same. They are still separate apart. The banana remains the banana, the apple remains the apple, right? So we cannot merge unlike things. Putting unlike things together will never be the same, because a banana can never be an apple and an apple can never be a banana. So therefore, remember, when we are sharing fraction and when we are adding or subtracting fraction, the portions must be the same. So whatever fraction we get, for us to actually add or subtract, then we have to have the portions to be the same. Now, the next thing you can ask them to do, now we need to ensure that 3/4 and 2/3 as the same portion, in the sense that, remember, the denominator tells how much the whole is divided into. So what we need now is for the John pizza to be divided in the same amount as what is the next person's name? The John pizza must be divided in the same amount as Anthony's pizza. Now here, they would know, they would have already known how to create equivalent fractions, right? So go ask them to go ahead now and create equivalent fractions, right? Now, after they have created the equivalent fraction, so they would now have 9/12 and 8/12. So the John share now becomes 9/12. I'm sorry, Anthony's share becomes 9 out of 12, and the Johns become 8 out of 12. So now the denominators are the same, mean each pizza is shared in the same portion, is divided into the same amount of parts. Now we can ask them to divide the John pizza into 12 parts and Anthony pizza into 12 parts. Everybody with me?
Yes, Miss, good.
Right, so you divide, so ask them after the talk. What I realized from experience is that this method, they grab it easily because they would have already known the equivalent fraction. They would have already have the shaded, so they would have already shaded the three parts for Anthony, and they would have already shaded the 2 parts for the John. So all know once they created the equivalent fraction, and they will now realize that each portion, each pizza is going to be divided into 12 parts. All they have to do now is to simply count, because the shaded part would have already been there. And you would ask them now just to count all the shaded parts for Anthony, write it down. All the shaded parts for the John, write it down and add it. Everybody with me?
Yes, Miss.
Yeah.
Right. So that's, and I am telling you, this has proven to be what students, this is something that I've used, and some students up to, even when they are in like grade 9, grade 10, instead of them to actually find the LCM, what they do is to draw the circle. Some of them draw the circle and they do it especially for addition, right? And because to them, when they find the LCM, some of them, you know, they got the mix up and stuff like that. But this, I'm sure that they will be doing it. They will be discovering it. They will be the discovering. And I know that we use the LCM where we ask them to find the LCM. So after they have done the shading and the drawing and the even folding and stuff like that, then we can go on to maybe ask them, oh, so maybe at that point we could give them the 2 questions, 3/4 plus 3/4 plus 2/3, and ask them how would they reach at the answer 17/12 or 1 and 5/12, and they would create their own learning as to how to add or subtract fractions, guided by you. Okay, everybody. Okay. Now, multiplication of fractions now. What is a half of 2 wholes? And remember again, this is what the students are going to do. We are going to ask them, students, what is a half of 2 whole? Some will jump out and tell the answer because it's easy. A half of 2 whole. You have 2 whole, half of one, half of the other. Everybody with me?
Yes, Miss.
So a half of 2 whole, easy, that is a half. That is half of 1 whole. And then you have a half of the other whole. And then a half plus a half give you 1. So a half of 2 whole is 1. Notice I didn't use the word multiply because although we know in mathematics, half means multiply. So it's after we have allowed them to use the shapes to understand the concept of mathematics, then we can go ahead and say, you know, half, and we can use the multiplication sign. So half and half, 1, right? Multiplication is repeated addition. And we prove that half plus a half, 1, half of 2 is 1. All right. Now, what is 2/3? No. Anybody have any idea using that shape? How are we going to help them? What is 1/3 of 2 whole? Again, 1/3 of 2 whole, that is 2 whole. What I want you to see the pattern here. All right, it says 1/2 of 2 whole, right? 1/2 of 2 whole. Look at this. I want you to look at the pattern and I want you to identify the pattern. 1/2 of 2 whole. Look, you have the 2 whole and then it is divided into 1/2. And we identify the 1/2 of the whole, right? And we get the answer. Let's go now. What is 1/3 of 2 whole? We have 2 whole and we divide it. We get the 2 whole first and then the next fraction. So the first one, the off one, off is the one that we will derive first. So we get the whole because it's said 1/2 of 2 whole. So we must have the whole first. And then it says 1/3. So we're asking for 1/3. So next we go ahead and we divide the shape into 3 parts and it says 1/3 of the whole. And we get 2/3. Any question? Everybody with me, any question? Anybody hearing me?
Yes, we are loud and clear.
We're here.
So there's no question, right?
Miss,
Yes?
you could also put the 2/1, right?
Yeah, you can put it 2/1, but because we are not actually, remember it's not solving now, they are doing the shading. You understand? And they are creating their own. But they could put it 2/1. But remember, this is not where you are doing, they are the one doing it.
Okay, then, all right.
Right, they are the one doing it, not you. So they are creating, so they are going to see. So you can ask them, what is 1/3 of 2 whole? So for them, they will have to create the visual in their mind, 1/3 of 2 whole. So first I have to have 2 whole, right? So they will have to know in their discussions, in their group, and then you can guide them. The first thing they will have to have is 2 whole. So after they have the 2 whole, 1/3 of it. So they will know if I need to find 1/3 of the 2 whole, I will have to divide each whole into 3 equal parts. Because remember, we must always remember that the denominator tells you what the whole is divided into, or what portion we're talking about is divided into. Everybody with me? So the
Yes,
2,
sir.
get the 2 whole, and then 1/3, so it now has to be divided into 3 equal parts. And remember, the top tell you how much is shared or how much you will have to shade. And that concept remains throughout. It doesn't change, it remains the same. So let's move on now. So they will have to do, so this is what we're expecting them to be doing in their groups. Given the shape, this is what we're expecting them to do. So they are the ones doing, not us telling them what to do, but reason and ask them to create. What do they need? Guide them through it while they are doing it. Next one is, what about 1/2 of a quarter? No, you are giving them the shapes. And that is why I said, notice the pattern. Let's go back. 1/2 of a quarter. It is not something that they're going to be writing down. This is the shapes that we are going to use them to do. We're going to ask them to use, and we are expecting them to use the shapes now to represent 1/2 of a quarter. Show me how would they solve 1/2 of a quarter. Again, let's go back.
Just a minute. I think Tessan Campbell would love to say something. Go ahead,
Okay.
Tessan.
Go ahead, Tessan.
Okay, she has muted her mic. Go ahead, presenter.
Okay, so let's go again. It says a half of 2 whole, half of 2 wholes. So the first thing you have to create the 2 whole. So I want you to see the pattern. After you have created the 2 whole, next, you have to divide it now into a half. And it said a half of 2 wholes. So it would be a half of one and then the half of the other because it's a half of 2 whole. Everybody with me? And then the shading, 1 half plus the other half, each is divided into 2. The denominator will tell you how much. 2 would it now becomes 2. The denominator would now becomes 2, right? Because they are the same, but let's step it up now. Same for this, because it is all half, 1/3 of 2 whole. Again, have the 2 whole. Next, 1/3, we have to divide the whole into 3 equal parts. 1/3 means 1 portion of each because it's 2 whole we're talking about. And we get our answer. Now let's step it up now where we are not dealing with a fraction. We are not dealing with a whole, but we are dealing with 2 fractions. Anybody has any idea how we could use this to help our students to understand the concept of multiplication of fraction in not just writing it and say a half, and if the numerator, I look at the numerator and the denominator to see what are the common factors, cancel, and then we put cancel if anything there, anything else is not left to cancel. We put multiply the numerator, write down the answer, multiply the denominator, write down the answer. How could we guide our students, giving them shapes to prove, to work out a half of a quarter?
Shadia is ready to speak. Go ahead.
All right, go ahead, Shadia.
Okay. So just as you've been using the shapes, give them the shape just the same.
Right.
So they're going to be working with quarters, finding half of 1/4. So they have to divide the shape into quarters.
First, very good. So the first thing, yes, so let's take it step by step. So the first thing they'll have to do is they'll have to divide the shape into quarters. Yes.
And then they'll have to establish what half means. You're sharing it into 2. So each quarter, you're going to share into 2 pieces.
Right, just a minute, guys, just a second. Just a second.
Okay, participants, feel free to place your suggestions in the chat. Feel free to type your suggestions in the chat. As soon as the presenter returns, Shadia Edwards Grant will continue her explanation. But feel free to place your comments in the chat. Those persons who wish to share how they would help students to perform this. All right, go ahead now, Shadia.
Okay, sorry about that, guys. It's just my son. I must explain that my son, just in January, he had for the first time, he had seizure, went to church and found him unconscious in his sleep for the first time. So at times when he screams out to me, I have to rush because I don't know. Just the other day, while he's sleeping, I have to observe him because all the tests were done and we haven't found anything, no brain, nothing. They don't know what is causing the seizure. So he had one the other day and it's just, and it takes him when he's in his sleep. So that's why I had to run once he called me. So I apologize for that.
That's understood, and we'll pray about it before this session closes.
Okay, thank you. So let's go. Somebody, Shadia was talking. Was Shadia? Yes, let's go. So the first thing, yes. So it says that we are dealing with a half of a quarter. So the first thing, as Shadia said, we expect them to divide the whole into 4 equal parts. Right. Next thing.
After that, now you'll have them say what half means. Since you're going to be finding half of the quarter. What does the half means they are supposed to do? And we would expect them to say each quarter will be shared into 2 pieces.
So each quarter will be right. So the next thing now, very good. So after they have done the quarter, they have done share the whole into a quarter, then they must expect that now they are going to know that they have to share each. Just a second, I don't know. Now they have to share each quarter into a half.
Right. So
Right.
after
Each quarter into a half. Very good.
Right. So after that is done now, they would look back at the quarter that was shaded to see how many pieces is there now. And then out of the total whole, how many pieces is there also. So the shaded portion would go to the top and the total would go to the bottom.
Very good. Very good. Everybody understand? Any question before I just add to what she said?
Could you please repeat?
Okay, so first of all, as you looked at the pattern that I was using, that when I was using the whole, I wanted you to see the pattern. Notice when we were talking about a half of two whole, first we get the whole, and after we get the whole, we look at the half. Now we have the whole, we have to take the half portion because it said a half of 2 whole. So when we identify a half of one, shade it a half, and a half of the other, we notice that a half put with a half, the 2 shaded portion, a half and a half will give us 1 whole. Just the same thing. We have 1/3 of 2 whole. So first we have to get off 2 whole. So we get the 2 whole. And then after we get the 2 whole, we now have to share each whole into 1/3. And then now the denominator of that 1/3 will tell you, the numerator will tell you what portion is shared. It said one of the 3 parts. Are you getting it? Are you with me?
All right.
Everybody
so that
with
would be
me?
2/3. Okay.
Right. So next thing now, just give me 1 second, please. Let me just keep on him and come back, please. All right, now? Huh? All right, I'll eat something, all right? Okay, sorry about that, guys. Next thing now we're looking at, and let's just go now. So it is a half of a quarter. So we'll have to divide the whole. We are expecting them now to divide the whole into 4 equal parts. After they have divided the whole into 4 equal parts, then each quarter now, because it said a half of a quarter. So a half means that now the denominator will tell you that now each quarter will have to be divided into 2 parts, because the denominator always tell you how much a portion is supposed to be divided into, or what is shared supposed to be divided into. Everybody with me? So the concept of the denominator remains. Next thing now, it says that, so after we have divided it, now you notice that there are now 4. It has now become 8 parts. So now the denominator would now be 8. Everybody with me?
Yes, because you would have shared each slice into halves. Right. So you end up with each slice will be divided into 2 equal parts. And so you end up with 8 equal parts.
Right. So the denominator now becomes 8. So the whole now is now divided into 8 equal parts. And remember again, the numerator always tell you how much is shared. So here now will just be a half of a quarter. So we'll take out a half of the quarter. So it's just 1. So our answer now would be 1/8. 1 second. I don't know something what's wrong with my phone. Right, sorry. 1/8. Everybody with me?
Well done, well done. Lovely so far.
Let's do another one now. So now, let me see if I have it. I'm going to share. Okay. Let's do another one. 2/3 of, again, anybody else? And somebody else would like to tell us how we do that with the shading now? 2/3 of 1/3. Somebody else. What would you do? Well, what do you expect them to do using the shades? Nobody wants to try?
Yes, Miss, I love to try, but I'm giving someone else a chance.
Yeah, exactly. Somebody else, please. We are using them. They're deriving their knowledge because up to now we have used the word multiplication. We are just simply ask them to find 2/3 of 1/3.
So what I would do is, or the child would do, is divide the shape into thirds. And take
Into
that
3 equal parts. Very good. So first thing, wait, just a minute. Once the screen once thing come up with their own one. It's too far. All right, let me hear it. So first they will divide the whole into 3 equal parts.
Right,
Yes.
one part representing 1/3. All right, and then I will divide all the thirds into 3.
Right, very good. Right. So the first thing you expect them to do, because again, always remember that the denominator tells how many, right? So the 1/3, remember it is 2/3 of 1/3, right? So we need to find the 2/3 of the 1/3. So after we have identified the 1/3, so we divide our whole into 3 equal parts. Now we need to find out how much is 2/3 of that 1/3. So here now we expect them to, after we have divided the shape into 3 equal parts, next we have to divide each 1/3 again into 3 equal parts. Everybody with me? So here now the denominator becomes 9. And it said 2/3, 2 tells you how many parts is shaded. So it would be 1, 2. So it would be 2/9 would be the answer. Everybody getting the concept now?
Yes, miss.
Or 2 9s.
Yeah, 2 9, sorry. Yes, he's okay. He said he's okay. He's up, Keela. He's sitting. I'm sorry, my daughter gets, because my daughter, she was here when it happened because I was at church and she was the one who witnessed everything. So once he calls my name, she becomes very paranoid. So I apologize for her, right? So everybody getting the concept now.
Quite lovely.
Yes, I will love
All right, so let's try. So what about this one now? Let's try another one. 2/5 of 1/3. So here I'm going to share my 2/5 of 1/3. Somebody else would like to try 2/5 of 1/3.
Sorry, did you change the screen? Did you?
No, something is wrong.
No, I'm just want to make sure that we're still seeing 2/3 of 1/3.
Yeah, I'm going to go to, I'm going to use my, sorry. I'm going to use my whiteboard to do this one. Or somebody could say 2/5 of 1/3. Let me use my whiteboard. Let me just minimize this.
Okay. We would be expecting them to share the whole into thirds.
Right,
So
into 3 equal parts. Very good.
And 2/5. So next they would divide each third into equal parts.
How many equal parts? Each third into how many equal parts? I never heard that.
5
Right.
equal parts.
5 equal parts. Very good. And then what happened?
And it asks for 2/5. Right.
They
but
take
first
out
of
2
all,
out of the 5,
they have
right?
to take out 2 out of the 5, but first they have to establish how many did they get in all to get the denominator.
Right. So the whole now is now divided into how many equal
How
parts?
many equal parts,
So
right?
how much could that be?
15. 5 3
Very
15.
good. Very good.
Yes.
Very good. Everybody getting it now? Do I have to
Yes,
show it? Everybody gets it. I don't have to use my whiteboard, right?
No, you don't.
Very
Uh,
good.
Could we also use fraction strips to demonstrate it?
Right. Yes, but what are fraction strips? Yes, but I would, for this one, the fraction strips, I would rather you use the fraction strips for division, because what I realize
Okay.
sometimes they mix up. I've witnessed where students have mixed up the fraction strips.
Yeah.
Sometimes they are doing the multiplication, but it's easier for them when they are doing the division. This
Okay.
have proven to work well. No students have any problem when they use this one.
Okay.
Mhm.
Madam Presenter, someone is requesting that the Jamboard, if you could demonstrate, that would be lovely.
All right, just a second. Give me a second. Are you seeing my Jamboard? I just switch. Are you seeing it?
Yes, we are.
All right, just give me a second. Let me bring up my. All right. Let me ensure that we are Jamboard. Jamboard. Just give me a second. Let it comes up. Jamboard sometimes give problem. Loading. You don't have Jamboard? What is this? Oh, sorry, I'm logged into the wrong account. Just give me a second. I use this one. Go to my, which one I'm in? Sharlene knows. Okay, I'm going to use this one. There's my stylus. All right, so first of all, the question says, is 2/5. So it is 2/5 of 1/3. But see my Jamboard?
Perfectly.
Yes, we are.
Very good. So the first thing we accept, they're given they are given the shape, right? Well, sorry about that. They're given the shape, right? Now the first thing they're going to do is they are going to divide the shape into 3 equal parts. Remember, this is a sketch, please don't kill me. Right? Because it said 2/5 of 1/3. So we first have to identify the 1/3 because it's from it the 2/5 is going to come from. Next thing now, they have to now divide each 1/3 into 5 because there are 3 1/3. So we have to divide each into 5 equal parts. We say it's a 2/5. And again, remember, denominator tells you how it is divided portion. So we're going to go now. Here's another hint. So I expect them to do 1, 2, like that. 1, 2, 1, 2, 3, 4, 5. Right? And then this one into 5. 1, 2, 3. Everybody with me?
Yes, so far.
1, 2, 3. Right. For real? Okay. So now each 1/3 is divided into 5 equal parts. So now the whole is now divided into 15 equal parts. Everybody with me? Now this number now is the one that is going to tell you, because it's only 2, it's going to tell you because it's the 1/3, because it's a 1, it says 2/5 of 1/3. So 2/5 of 1/3 will be 2/5 would, oh, let me use another color marker. So 2/5 of 1/3. So taking out one of the 1/3, 2/5 of it. So the number of parts shade, 2/15. Everybody with me?
Yes, we are.
All right. And let's try now 2/4 of 2/3. 2/4 of 2/3. So somebody would want to try this one for me?
Please repeat the numbers.
I'm going to write it on the screen. 2/4 of 2/3.
You want me to go ahead?
No problem. No problem.
Yes, because the first one I didn't, I make sure to my drawing, you know. So first I'll have my circle. And
Okay, let me draw it for you. Let me do the
mhm.
demonstration.
Yes.
All right, so you'll do your circle,
That's a
right?
big
So the
round
kids would
one.
already have their circle.
And I will establish 2/3 in that one. So divide it into 3 equal parts.
Very good. So we divide it into 3 equal parts.
And I will shade 2/3 of that shape. That means 2 of the sectors.
Well, remember, I know it is not 2/3 we are concentrating.
Yeah,
yes?
man, I'm telling
It
you
is
what I will
2.
do.
Okay, okay,
I'm
sorry. So
telling you
you'll
what I
shade.
will do.
Okay, sorry, no problem.
Yeah, to
So you'll
establish
shade.
the portion that I'm focusing on. Yeah.
They'll identify here.
Yes, right. So that's my
Okay.
2/3. Now 2/4.
Okay.
If
very
you
good.
wish to, it's the same as a half. But if you want to work with the 4 as denominator, I would
The
divide
4 is the
each
denominator,
yeah,
right?
I would divide each sector into 4 equal parts now.
Very good. Because remember that we are not doing the reduced fraction, yet, you understand? We are
Yeah,
trying
man. We're trying to build conceptual understanding.
Right.
Which I love this.
So we divide it into 4 equal parts.
Yes, because my denominator says each part should be 4 equal parts.
Very good. So we have
no man.
4
Finish divide that first one. Yes.
Yeah, man.
No man, the first one.
1, 2, 3. Sorry.
Yes.
I'm not seeing well. Very good. 1, 2, 3.
Yes.
4. 1. Right. See here. Okay. So
and
now,
no, it says 2/4 of that. So I will shade 2 out of 4 equal parts of each sector of the sector that is shaded. 2 out of that 4 pieces there and 2 from the next one.
Very good. So very good. You're getting it. So here now we identify with this, right? These are all 1/3, right? Remember that one of the 1/3 is this one, and one of the 1/3, because it said 2/3 means 1/3, right? Because 2/3 means 2 1/3. Okay.
Yes, miss.
So now, after they have done, now they have to shade 2 of each. So you're expected to shade 2 from this, and 2, and from the other one, 2 from the next 1/3, right? So our answer now, remember now our denominator becomes
Miss, you want me
12,
to finish?
and we have 4.
Yes. So I count up my equal parts, and I know that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I put that as the denominator.
Right.
And I end up with 4 parts being shaded there that I'm focusing on. So that's 4 12s.
Right. All right. Want us to move on to division, or you want to do another one? Want us to do another one? Or can we can move on? No answer?
We can move
Come on,
on.
people, speak up. I guess someone said can move on.
All
We
right,
can-
so
I want us to do another one, but
All right.
tell me, what if it is multiple choice, right? Would they put the 4/12 as well as a third?
remember, it is still in the concept, you know, it's after they have done the concrete, now they are going to go into the abstract.
Okay, all right.
Right, this is building the concept, you know. This is where they are building the concept, understanding the whole concept of fraction, where we're not just going to write it on the board and say 2/4 times 2/3. Look at it, anything, look at the denominator, look at the numerator, any number can cancel top, bottom, and we say top, bottom, diagonal, diagonal. So they are going to say, okay, Miss 2 going to for across all the 2, put the 1 plus. We don't, we want them to understand the concept, the concept of multiplication of fractions. Then we can go into where now after they have understand the concept, we go now to the abstract, right?
Yes, miss.
And as I said,
I get all of that, and I'm into it as well. But I was just I read.
no man, you can let them reduce it, no problem. Yeah, man,
Okay,
you can
that is what
yeah.
I'm asking.
Yeah,
Okay.
yeah, man, if reducing
So
is
we
no
get the
problem.
concept. We get the
Yeah,
concept.
right.
And I like
So, so we can move on now.
Wait,
Or
miss,
oh.
even, just a minute, even with this one here, if
Mhm,
they were to even say, put the pieces together that are shaded, the
mhm,
2/4 of that 1/3 and the 2/4 of the other third. If you put them together, you know, you really get 1/3 of the whole.
exactly.
Yes, that's all.
Exactly, exactly. Which is which should be reduced. And this is what you want your students to discover. And these are the things you want to hear coming from your students. Okay? So somebody else said let's do another one.
Yeah, I had said so, but
You're okay.
yeah.
All right. Okay. So let's move on now. Where's my?
The one that says multiplying and dividing right there at the top.
Wait, I'm trying to find back to meeting. Wait there. I'm trying to find my PowerPoint. Just give me a second.
That's what I'm telling you. Look at the top where you have Jamboard, go across, you see multiplying and dividing. Click on that tab at the top of your
Wait,
screen.
just a second. I'm seeing wait there. Just a second. You see, because it's blocked, I'm not seeing. All right, wait. Let me close the Jamboard.
Don't close that one. Don't close that one. That's it.
Yeah, I realize. So, all right, now, just give it a second. All right. Division of fractions now. And this one says, again, how many 3/4 can I get from 3 wholes? How do you expect your students to answer this one now? How many 3/4 can I get from 3 wholes?
Expect them to, first of all, draw their 3 holes. Get the 3 holes. Share the 3 holes into quarters. So each of them should be divided into 4 equal parts. You're going to take 3 pieces from each of your 3 holes and count them.
But if they are going to end up with 9 pieces. Right? If they take each piece,
yes,
it's 9, but they didn't ask for 1/3. They didn't ask for a quarter. They said 3/4 of How many 3/4 can I get from 3
Yes.
whole?
Quarters, yes, so they're going to separate them into 3/4. So you're going to take out one set of 3/4, another set of
Right.
3/4, another
Very
set of
good.
3/4. You're not
Yes.
going to mix them together. And then you
Yes.
count how many 3/4 did I take out.
Right. So how many
You're not going to be
3/4?
counting the pieces single. So
Very
that
good.
would be 3/4 that I get from my wool.
Very good. Very good. Yes. So they will get 1 3/4 from here, 1 3/4 from here, and another 3/4 from here. So it would be 3 3/4. Right?
Yes.
A half divided by 1/3.
Excuse
But
me.
what you could,
Excuse me, miss. Hello, can I speak?
Oh,
yes.
sorry.
Good afternoon. That question, how many 3/4 from 3 holes?
How
After
many
you take out,
3/4 can I get from 3 holes?
after you take out the 3/4 from each hole, the
Yeah,
other
one.
3/4 that are left, wouldn't that be a 3/4?
It would be a 3/4. But remember, the whole is an individual, you know. We're not adding, you know. Remember, it's division. It is how many 3/4 can I get from 3 whole? Don't
I
mix
would
up.
say 4. I would really say 4. So that would get me.
It's 4. Sorry. 4 is the answer. I apologize. You're correct. How many 3/4 can I get? This is so right. It's supposed to be 4. You're so correct. 1 right here.
One.
My bad. I apologize. It would be 1 right here, 1 right here, 1 right here, and then each quarter there are 3/4. So it's supposed to be 4.
Yeah.
And if you do the cancel, you're going to get 4 if you do the division. My bad.
Not
Okay,
just your
thank-
bad, not just your
thank you.
bad, but myself here looking at it, I wasn't even thinking about
Right.
the
It was a
quarters.
big
The
mistake.
fact that we have 3/4 there at
Right.
the top
It is
of each,
3,
so that's also
and we
a
are
3/4.
expecting, and please do, when your students make the corrections, then you know that they are learning, right? So they would identify that they are, because 1/4, so it would be 3 would be 4. So please, because if you even do the calculation, 4 should be the answer. I do this when I wasn't thinking. All right. So let's look at this one now. All right. Let's look at that one. So here now, it would be we using we could use fraction strips. So here now we would use fraction strips. We can, so I'm going to show you where they can do the dividing, and then we can use it, and then we move on to how we can help them to use the fraction strips. So how would you guide your students into solving this problem now? Okay, Shadia.
All right, so since we're dividing a half by a quarter, you get the whole, but you're focusing on half of it. And you're dividing it into quarters. So you cut it into 4 equal pieces. And to see how many quarters you can get out of the entire whole, you'd have to count up the pieces when you're done to see how many 1/4 there are in the half. Sorry, not the whole, the half.
It's just a half. You're concentrating on, you know.
So you would cut the half into 4 pieces.
So you'll cut
the half
you're
into four pieces to see how many.
It says a half divided into a quarter. So remember, we have the whole.
Yeah, but then
right?
we're focusing on the half, so we'll divide half.
Right. So we'll take now the half, but if you divide, no, so after we have done that, we're going to divide the whole into a half. So we have to take one of the half and divide it into
quarters.
Let me hear it now.
Into 4.
Remember, it's the whole same way now. Division.
But you're working with half. So you divide
right.
it.
So we're just working with the half. Right? So although it would be divided it into 4, anytime I do the admit, it freeze, right?
Okay, you don't have to do the admits. We are the ones who should
No,
be doing
anytime
it.
it comes on, not with the admit,
Oh.
every time it comes on, it freezes my screen. All right, somebody, 2 persons raise their hand. Let me hear
Yes,
the question.
Chadia and oh, Chadia only no. The other person has lowered the hand. Go
All
ahead,
right.
Have we
Chadia.
identified the half now? You would have to say how many quarters you can get out of the half. So you
Right,
divide
so
the half into quarters.
Right, so you divide the half. You divide the half because you now divide it into a quarter, right? So the whole now would have to divide into 4 equal parts, right?
Right,
However,
the whole
you
should be
just
divided.
going to take out the half. You just going to take out the half because it said a half divided by a quarter. So although the 4 is going to divide it into 4, all divided into 4 equal parts, it is just the half you're concentrating
But you'll be
on.
counting the pieces for.
Right, so you'll get 2. Everybody with me?
Yes, and you can also see that 2 quarters. When you put 2 quarters together,
Right.
you get a half.
Very good.
Right.
Right, and these are the discussions that you're expecting to hear coming out from your students. Now, let's use the fraction sticks now. Now, the fraction sticks, once I said, let me freeze up, right? The fraction sticks really makes it easy, the fraction sticks, right? So here we have a half divided by 1.
You rushed that a bit. Could you just review? Yeah.
No, it's just that we were just working half divided by 2.
Okay.
Do the calculation just to prove. Okay, 2 persons raise your hand. 2 persons want to ask something?
I'm seeing Ashley DaCosta. Ashley, go ahead. All right, Ashley, could you kindly unmute and speak? All right, Mr. Brown has chimed in. Mr. Brown? Okay, Ashley? All right, I'm not sure if Ashley's heard me at all.
That's Carol coming. Or the chat.
Oh, okay. All right, checking in the chat. Carol says, I'm wondering if you put the half by itself, children might begin to think of it as a whole. All right, so perhaps I'm
in a workshop. Let me tell you, I'm in a workshop or something. Sorry about that. Yes. What were you saying now?
Carol, do you care to unmute your mic and clarify your statement?
Oh, she said that if you put a half by itself, the children might think of it as a whole. I'm not getting. No, he's not putting it by itself. You know what happened is that I just took it apart. All right, maybe because it's not going to be by itself. Let me go back to it. Wait,
yeah, I understand what she's saying, but
yeah,
you
it's not,
had it together.
oh, because I took it, this other part is supposed to be a joint to it, but because I just want you to highlight, but they will have it. So it will not be separated. Are you getting me? I just took it apart. I just took it because I just want you to see where they will identify the solution. Okay. Oh, she said okay. All right. Let's move on now. Now we use the fraction strips. No. And the first question is a half divided into 1/8. So now the first thing we're going to do is we know that the fraction strips, so you get remember that when we have the fraction strips, so how we allow them to create the fraction strips. So if they have a whole, and then the same whole must be subdivided into a half. Then we split each off into a quarter. So when you finish, then a quarter, 1/8, then 1/16, and then it's supposed to fit exactly onto each other. So if you take the parts that, if you take the whole and you put it flat, you take the parts that is a half, put it onto the whole, it must fit exactly onto it. Take the quarters, put onto the whole, it fits exactly onto the whole. So each of them must be coming from the same shape, exact same shape, right? So so we give them the fraction strips. We're expecting them to identify a half. So they are going to take out their half fraction strips. Then they are going to get the 1/8 fraction strips and see how many can fit onto their half. Everybody with me?
Yes, miss, that's how I do it.
Right. So you get their half fraction strip and you let them see how many can fit 1/8 can fit onto their half. And they will realize that 4 1/8 fits exactly onto a half. Okay? So a half fits, 1/8 fits exactly onto a half 4 times, so our answer would be 4. So that means a half divided by 1/8 gives us 4. Next one. So we have 2/3 divided by 1/6. So we get, for this one now, they will have to get 2 1/3 strips and put it beside each other. So you get 1 1/3 strip, another 1/3 strip, put them together, get the 1/6 strips, and see how many 1/6 strips is going to fit exactly onto the 2/3. And then they will realize that it's 4. Okay? Moving along. No, 3/4 divided by 1/8 again. Here we'll have to get 3 quarter sticks, put them beside each other. We'll get them, let them get the 1/8 and see how many fits exactly onto the 3/4. And after they have done that, you can get as much as you want. Use a fraction stick. Let them try. Let them try them. After which now you can move from, you can give them a table. Now you're moving to the abstract where you just give them the problem and ask them, this is the problem. How do you get from the problem to the answer 4? Now, there are 2 ways to do division. I don't know. Some persons do the cross product. So it would be 2 times 6, which is 12 over the 3 times 1. Has anybody ever seen it like that?
First time hearing of that.
Right.
But I know that
can,
when you change the sign, you write the inverse of the divisor.
Right, we all know that one. But we can also let them divide. So instead of keep, change, and flip, do the cross product. So we write the 2 over 3 divided by 1 over 6 cross product. This leading diagonal, we call it leading diagonal. So from left to right is called the leading diagonal. So we multiply the lead numbers in the leading diagonal. So it would be 2, sorry. So it would be 2 times 6. So it will be equal to 2 times 6, which is 12, over 3 times 1, which is 4, which is 12. 3 times 1, which is 3. So 12 divided by 3 equals 4.
Yeah.
Yeah. And the end. Thank you. Now, what you can do, guys, before you can create worded problems and let them create the fraction, the number problem, the number representation of the words, and work through to get their solutions. Thank you.
Wonderful, 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 wonderful. What a mouthful that was. All right, I hope everybody drank in all that was said. You did such an awesome job. So I'm just gonna allow everyone to at this time, if you so need to express yourself, to say thank you, to show your gratitude to Miss Sharlene Mills for giving of herself in such a wonderful way. All right, so we're looking in the chat. Miss Maris Adams, are you with me here? Thank you, Miss from Don Salesman is saying very good presentation. Thank you. I think I missed a few. All right, somebody was saying reinforcement, very good presentation, Miss Mills. All right, this is such a beautiful presentation. All right, awesome. So we want to express our thanks to you, Ms. Mills, for what you have done. Words are not enough to say thank you. I don't know if some persons have saying that some persons may not have seen it in this way, being delivered this way. We are used to just jumping over the real into the abstract. Just starting to multiply, and sometimes we have not taken the time but the concrete to set for the students to get that and to gel so they can feel on it. So what you have done is that you have set the stage for teachers to go off and to implement this in their classroom and to have students loving fractions. All right, we're looking forward to having you again with us, and we just want to say, Artie, thank you. It would be nice if somebody opened their mic and actually express. I've seen it on in the chat, but so you can open your mic and say, whatever you want to express to her. I'll give you a minute or two. All right, go ahead, Dave. Yeah, Lorraine.
Good evening again, everyone. Really appreciate the presentation. Each time I come to one of these presentations, I learn so much. I love the use of the circle. I normally do with a rectangle, and as you said, it can become a bit complicated. Really appreciate it. But I have just one little question. If you are using whole number, or mixed number, sorry, not whole number, mixed number, how would this method work for the multiplication and division? Great presentation. Awesome.
Over to you, Ms. Mills. Did you hear that, Ms. Mills? Oh, your microphone is closed. Oh, you're muted.
Unmute your mic.
Okay, sorry.
Okay.
Right. So you can it can work because you will now convert it to an improper fraction and let them convert it to an improper fraction and do the same procedure.
Okay. All right, so that sounds like another workshop that we're going to look forward to you actually extending or expanding on what you have just done. All right, is there anyone else? Any other question, any other comment before we bring this workshop to a close? All right, again, on behalf of QEC 54 and the Math grade 4 to 6 PLC, we just want to say thank you, Ms. Mills, for sharing with us today. And in any way we can, we will look forward to extending our thanks in other ways to you because you have enriched the life of these teachers. We had more than 30 odd teachers on. Some stayed for the entire duration, others came in, and you know, because of the length of time, others had to go. But we are grateful for what you have done. All right, I just want to say thank you to all the persons that were here that participated in today's workshop. I hope that you have taken something from this workshop and indeed will continue to enrich the life of your students as you continue to come and join us and share in the various workshops we have. Next week when we meet, we will not be doing a workshop, but really what we'll be doing is that we'll be looking at conceptual understanding, conceptual and procedural understanding as we look at tweaking different lesson plans so that we can meet the needs of our students. All right, a blessed evening to you all. Bye for now.
Okay, Miss Shanice Morrison, please end the recording so we can Move